This is the multiple linear regression. Dependent variable y is a function of x, but it's not only x, maybe y is function of y is a function of x1, x2, x3, and it's more than one. It depends variable is to multiple linear regression. It's still like linear equation. Like for example, this is the linear equation is multiple with a function of x1, x2 until xk. This is linear, but for this is x squared x over 3. This is non-linear. But also we can transform from non-linear to linear by this. We convert the variable by x squared is x2, x is x1, x is x2, x out is x3, right? And then you can find beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3. When x1 is x, x2 is x squared, x3 is x over 3. This also we can transform non-linear to linear. This is linear, it only is function of x1, right? This is x1, x2, x3, for example. This is the technique. Now this show you the curve, three-dimensional curve. This is for non-linear. This is a non-linear profile. This is response surface for non-linear. And also for this case, we can transform from x1 square equal to x3, x2 square equal to x4, x1, x2 equal to x5. Because this is term of non-linear. This term is non-linear. Non-linear term. And also we can transform to linear like this. And the technique to estimate the parameter b beta, beta 0, beta 1, beta 2, beta 4 is also we call the least square technique. The square technique that we calculate error is defined by L. L is the error square. Error is mean the actual value yi minus the predict value or value that we obtain from fitting equation like this. After you fitting y as a function of xi, you get the equation like this. You use actual value for y at any x minus the predicted value that you substitute as x to this, and then you get the error. Because the error we have both negative and positive. And for this case, we use square error. We got the error square we get positive. If you use the error, it may be negative, positive. If you sum up, it may be cancelled. But if you use the square error, when you sum up, it's not cancelled for this. And also for this case, we can use the same thing with the simple linear regression. You have to differentiate L with respect to any beta, with respect to beta 0, beta j, beta I, beta k. For example, if you with respect to beta 0, another beta is constant for this. And finally, you get the linear equation based on x value, and also y value. As I said, term of this, we get the metric. And also, this is some the data for multiple regression. We have the response or dependent variable value with x1, x2, x3, xk, for example. x1, x11, x12, x1k, x2. This is based on one is y1, y2, like this. Okay, for the first example, we use the data on processing of a board in a semiconductor using process wide length and die height. It is the independent variable that affect to processing. This is y. This will represent by x1, x2. Y depend on x1 and x2 in terms of linear equation. We represent by this. Y is a function of x1, x2 in terms of beta 0 plus beta 1 x plus beta beta 2, x2, right? And we have some error for this. And the data of this shown in this is the data that shown. This is the whole stem. This is x1, x2. For that we have 25 data. Now to fit this data into y equal to beta 0 plus beta 1, x1. x1 is the y length plus beta 2, x2. x2 is the die height for this. So if we represent, like for each term, we plot strength, this is strength and length, y length. We find this y length increase, strength increase, or we plot strength with y-axis and height. For the height increase and length, strength is etc. Like for sketching, not a function, not a pattern. Cannot predict that when the die increase or decrease, effect strength increase or decrease. And if we look at this is the length, and this is the y is length, and x strength is also linear relationship. Length, this is height, and length is not pattern also. But for this is the length in y-axis, height in x-axis, no pattern also. But for this is the height is y-axis and strength y-axis, no pattern also. We can see the variability of the die height and the y length with two strength. Okay, if we look at the general equation for this, we have x1 and x2. We have what? For this, we use this three equation. This metric 3 multiplied t. This is the equation that we have to n is 25. Summation yi, like you sum of y. This means you sum of this, sum of this value, sum of this value. You sum yn sum xi, sum x2, to sum x I1 square, sum xi1, xi2, x1 y, x2 y, x2 square, x1, x2 y. For this, you have this term already. And then you substitute this term into the metric. Now into this, you get the value like this. You get the metric. We have three equations. Equation 1, equation 2, equation 3. And then we have three unknown, beta 0, beta 1, beta 2. We have three equations, three, and we can solve this equation. And then you get beta 0, beta 1, beta 4, like this. This is the equation representative y, the function of x1 and x2. You can use the metric solving for this. Okay, if we look at this, the general technique to solve this. From previously, we have the data in y, because it's metric y, and metric x. Metric x, we say is 1, 1. This is xi1, xi2 until xik, y xik. For this, that means 1 multiplied beta 0 plus xi1 multiplied beta 1 plus xi2 multiplied beta 2 plus xik multiplied beta k equal to y1. You get equation, right? You get this equation. Okay, for let's get it from this metric y, metric x, metric beta, metric L. Like this is y equal to x beta plus L. And then you find the square L. Square L equal to y minus x beta transpose multiply y minus x beta. For this. For the square method, you try to diff with respect to any beta equal to 0, and then you can solve for beta for each step. Yes, for let's get how to solve this. And then from this, the x transpose multiply x multiply beta equal to x transpose multiply y. And then you can solve for beta equal to x transpose multiply x. This is inverse. That means inverse of x transpose multiply x transpose multiply y. You get the result. Right. Okay, this is the general equation. This metric This is you know from data, right? And this is the metric beta. This is metric y. And this all this you obtain from the data. All this you obtain from the data, and then you can solve for the metric beta for that thing. Like the step for solving, and also the for solving, you have to solve by beta equal to metric inverse of x transpose multiply x multiply x transpose multiply you get beta, and then y equal to beta. This is the general equation. Y equal to beta 0 plus summation beta jx. It depends on number of x. Now in metric notation, we use metric y equal to metric x multiply metric beta, and then you can calculate the error or residue. Sometimes we call this the actual data of y multiply predict or fitting data. That means you substitute x to the predicted equation to get y predict. This is some error. Okay, from the previous example, right, from here we try to fit this is metric x from the data. This is if you look at the data. Okay, this is one, right? This one. This is one. We represent by the first law as one. The second law is x1. The third law is x3 or x2. Right? This is come from the data. Now this x. This x1. This x2. Right? This is the second and the third law we represent by x1 and x2. The first law is represented by 1 because the coefficient multiplied beta 0 is 1. For this case, you look at this, this is 1 multiplied beta 0. This is x1 multiplied beta 1. This is x2 multiplied beta 2. Okay. Metric x is 1. First law. First column is 1. Second column is x1. So sorry. x1, second column. The third column is x2. Right. And metric y is the response of y value. Right. For this. Okay, you know of this. You know metric x, metric y, and then you can solve beta by this. Beta is equal to metric inverse of x transpose multiply metric x. Multiply metric x transpose multiply metric y. Metric transpose you convert from law to column, column to row. But from previously, if you look at the metric x, this is metric. This is 3 multiplied 3 metric. 3 multiplied 25. Sorry, this is metric 3 column. 25 multiplied 3. 25 log 3 column. 25 log 3 column. And then for transport, it's maybe 3 log multiplied 25 column. This is metric transport. If for this case, the 111 is equal to first law. This is the second law, this is the third law. Right? This metric transport. And then you get metric x transport is 1 until this. This is x1, x2. Multiply x is also 1 is 2, and this is x1. This is x2. Okay, you get this metric. You found that metric. This is metric 3 multiply 25, multiply 75, multiply 3. You get the result is 3. This is metric 3 multiply 3. And you get x transpose multiplied x. This is x transpose multiplied x. This term. And also x transpose multiplied y. This is x transpose, this is y. Right. This is x is 3 multiplied 75. 25 multiplied 1. You get metric 3, 1. 3 law, 1 column. Like that. You get x transpose y. And then you find the inverse of x transpose x. Multiply x transpose y, you get beta. Okay, the beta equal to x transpose x inward multiply x transpose y. So this is x transpose x. This is y. This the result is inward of it multiply y. You get this result. This is beta. Right? This is beta, and then you get equation of y is a function of x1 and x2. x1 and x2. For that case, if you would like to calculate error, that means you substitute x1, x2, and then you get y. You have 25x, you substitute x1, x2, 25 times, and then you get the error is 25 value. For that case, if we use x1 equal to 2, x2 equal to 50, for the first data. The first data is 2 and 50. You substitute x1 and x2. You get the first result, which is x1, x2. x1, the first law, x2, the first law. You get this y. That's right. Okay, and then you minus, this is y data, this is the actual data. This is the actual data. And then you substitute x1 and x2 in any, like this equation. And then you get error. You get the value of y predict from the fitting equation. And then you get error. You get error. This is error. If for this case, if I show you by Excel, right? In Excel we have the metric, metric multiplication, metric division, metric transport. We have the metric built-in function. But this is the metric x, metric x, metric y. And then for calculation, you have to multiply metric x transport multiply x. This is the metric transport. Transport is 3 log multiply 25 column. And then you multiply x transport and x, get this. For this, and also I will show you by Excel first. It's better to understand this. Okay. The first step I want to solve this. Okay. This is the metric x, 25 log, 3 column, metric y, 25 log, 1 column. Okay, the first step we have to calculate metric x transport. Okay, metric x transport is 3 multiplied 25. That you have to choose the cell 25 column T log. Okay, this is 25 column T log. And then you enter equal metric transpose, right? Metric transpose, M transpose, suppose. Okay, this is transpose. You choose this transport. Okay, you have to select transport of this metric. You select all of this. Okay, and then okay, and then you click Control Shift Enter. Right. For that, you get the metric transport for this. Metric transport for this, because it's a visit from first column, it should be first law, right? Second column is to be second law. Third column is to be third law. That is only this. And then the second step, you multiply metric x transport with x. Metric transport with x. Metric transport is 3 multiplied 25. Multiply metric x. X is 25 multiplied 3, right? And finally you get the result is 3 multiplied 3. 3 law, 3 column. That's it. Okay. You choose 3 law, 3 column. And then mult, yes, MMULT, metric transport between array 1. This is metric transport. We collect metric transport. Comma, array 2 is metric x. Right. You select metric x. And then Control Shift Enter. Right. This is the metric x transport modified. X transpose multiply X. The next step, we find metric X transpose multiply Y. X transpose is 3 multiplied 23, 3 log 25 column multiply metric Y. Metric Y is 25 log 3 column, 1 column, right? 1 column. Then you get 3 1, 3 log 1 column. Is our result. You have to get 3 log 1 column. Enter MNULT multiplication of X transpose, which is X transpose, comma. Array 2 is X transpose, and Y. Which Y? This is Y. And then control shift enter. You get this is the metric X transpose multiply Y. X transpose multiply Y. And finally, you calculate the result. Please. The result equal to beta equal to X transpose X inverse multiply X transpose Y. You know X transpose Y, you know X transpose X, and then you calculate inverse of this. Right? It maybe you call like M inverse. Right? Okay. We have 3 log 1 column that side equal to ML multiplication of X transpose X inverse. Okay. Inverse. M inverse. Okay, M inverse. M inverse of X transpose. And X transpose Y. Control shift enter. Right. You get this result. 2.26, 2.7, 0.01. Yes, you get this beta. This is beta, right? You get this the same result that we talked by pivot technique. Okay, I will stop for lecture for the I will continue for the next.